going to discuss in this class quinine. The subject is quinine, a famous febrifuge, a famous anti-malarial drug. Quinine is used medicinally as anti-malarial drug as well as to reduce the fever, that is as a febrifuge. Normally, the quinine is extracted from a plant, namely cinchona. In particular, the bark of cinchona tree is used to extract the drug quinine. In turn, that goes as anti-malarial action. The topic is quinine, famous anti-malarial drug. Famous anti-malarial drug. Its structure is OCH3. Here we have exactly like quinine. Apart from this, there is CHOH, and in turn this is connected with your nitrogen, and here CH double bond CH2. This is your quinine. CH2 CH2, then connection. This is your quinine. This exists as LEO form, therefore always written as minus quinine. Its boiling point is 177 degrees Celsius. And the source of quinine is bark of cinchona. Cinchona bark. Cinchona, nothing but the name of the plant, name of the tree, and its bark is used to extract the medicine called quinine. This is the basic structure of your quinine, and its formula is C20H24. C20H24 N2O2. This is the formula of quinine, and this is the structure of quinine. Boiling point is 177. It is mainly used as anti-malarial drug, and the extraction, the source of extraction is the bark of cinchona tree. Now, what we are going to discuss in this class is about the quinine, the elucidation, structural elucidation of quinine based on the different reactions, and with the help of all those arguments and the reactions, finally we are going to conclude the structure of this quinine, and after that we will try to have the discussion on synthesis of quinine. See here, this is the formula you know, C20H24 N2 and O2. And when you look at the structure of this quinine, you can see there are two nitrogen, the two nitrogen in tertiary position. Therefore, we have a this is nothing but a di-tertiary base. We can conclude simply by looking the structure. What we are arriving, the conclusion is, the first point is, this is a di-tertiary base. And apart from this, there is a hydroxyl group, and the nature of this hydroxyl, nature of this alcoholic, the functional group is secondary alcoholic. And apart from this, there is one ethylenic double bond, one ethylenic double bond, and apart from this, we have a pyridine ring like. It's exactly pyridine, and the pyridine is fused with benzene, and in turn with the benzene there is a methoxyl group. There is a methoxy group. There is a methoxy group. So we have one methoxy, two nitrogen, that to a tertiary position, and one secondary alcoholic and one ethylenic double bond. These are the clues we get simply by looking the structure. Number one is methoxy group is there. Methoxy group is there. Number two, one double bond is there. One double bond is there. And number three, two tertiary nitrogen is there. Tertiary nitrogen is there. And number four, we have one secondary alcoholic is there. So these are the few important points we are arriving based on simply the looking of this structure. The clues what we get is one methoxy is there in the structure of quinine, one double bond is there, that is one ene is there, two tertiary nitrogen is there, one secondary alcoholic functional group is there in the structure of quinine. These are the things we are going to confirm whether really we have a methoxy one double bond, two tertiary nitrogen, one secondary alcohol. All these things we are going to discuss under the topic very shortly. That is, after this, the topic is structural elucidation of quinine. Of course, this is a continuation of this. So see the board. I'm deleting this. Quinine, extraction source is in bark, anti-malarial drug. Quinine is normally used as anti-malarial drug, also as fever reducent. Simply it will reduce the temperature also, therefore this can also be used as a febrifuge. Its boiling point is 177 degrees Celsius. Formula is C20H24N2 and O2. This is the structure of quinine. In the quinine we have a one methoxy group connected with the benzene part of your quinine. There is a pyridine. The pyridine is connected in turn with your secondary alcohol. There are two tertiary nitrogen, one ethylenic double bond. One ethylenic double bond. See the board again. Try to keep all these points, whatever I said right now, so that it will help you when we are discussing the structural elucidation of quinine. Yes. Now come to the next point. I'll keep the quinine structure here just for reference. OCH3 here, and we have CH, OH, then we have a nitrogen, and here we have CH double bond, and here there is CH2. CH double bond CH2. This is your quinine. Now come to the point. Quinine normally reacts with two molecules of methyl iodide, gives Di-quaternary salt. Quinine, instead of writing the entire name, the complete name, simply I write Q, where Q stands for your quinine, reacts with two molecules of methyl iodide, gives you di-quaternary salt. Di-quaternary salt. Di-quaternary. Simply, you know that this is your quinine. Quinine reacts with two molecules of methyl iodide. What will you will get this one? Yes, this is a quaternary salt. Quaternary salt like this. You will get to two quaternary salt, di-quaternary salt. Two quaternary salt. One here, another one in the tertiary nitrogen of the second. What we have, the second nitrogen also in tertiary position. Therefore, you get, whenever we treat the tertiary nitrogen with methyl iodide, it will give you the quaternary salt, quaternary ammonium salt. So, based on that particular general reaction, since the quinine consists of two tertiary nitrogen, the two tertiary nitrogen reacts naturally with two molecules of methyl iodide, gives you di-quaternary salt. Ultimately, this confirms the presence of two tertiary nitrogen. So, the nitrogen what we have, the two nitrogen in quinine, both the nitrogen is in tertiary position confirmed by this particular reaction. We have the nitrogen in tertiary position. Tertiary position, reaction number 1 reveals. Reaction number 1 confirms the presence of nitrogen in tertiary state. Next reaction. Quinine reacts with hydrochloric acid. Remove one carbon as methyl chloride. Second reaction. Quinine reacts with hydrochloric acid, thereby removing one carbon atom as methyl chloride. Gives you the corresponding product. Methyl chloride is getting eliminated by removal of carbon. That carbon reacts with your HCl, that is a Cl portion of your hydrogen, HCl, gives you the product that contains naturally one methyl group less, and this confirms the presence of OCH3, that is methoxy is there. This methoxy OCH3 reacts with hydrochloric acid, and this CH3 connects with your Cl, part of your HCl will be converted into CH3Cl plus OH. Yes. So this confirms the presence of your methoxy group in the quinine. The second reaction reveals the presence of your methoxy in quinine. And the third reaction is quinine gives monoacetate and monobenzoate. Monoacetate and monobenzoate. What it reveals? This reveals the presence of one OH group, only one OH group, and that OH group in secondary position. That OH group is in secondary. That also I will confirm why I am insisting it is a secondary. So the monoacetate formation. Whenever quinine reacts with the corresponding reactant, confirms the presence of one OH group, one alcoholic group, and that alcoholic group in secondary position. And this is confirmed by the fact that quinine on oxidation gives you a ketone. quinone. Remember, quinine gives one quinone, a ketone, only when there is a secondary alcoholic. Only when there is secondary alcoholic. Only the secondary alcoholic will be converted into ketone on oxidation. No primary alcohol, remember. Primary alcohol, never. That is, it will not give you directly the ketone. Secondary alcohol alone undergo reaction, that is oxidation reaction with the corresponding oxidizing agent. Say for example, chromic oxide. The chromic oxide oxidizing your quinine into a ketone, that is, its name is quinone. This confirms the presence of secondary alcoholics. Confirms the presence of secondary alcoholic. So we have confirmed that the presence of alcohol in quinine as secondary alcohol. Next. So we have confirmed the presence of methoxy with the help of the first reaction. We have confirmed the presence of your ditertiary nitrogen, and we have confirmed the presence of secondary alcoholic also. Secondary alcoholic also. Now we are going to discuss the next one. This is OCH3. OCH3. Quinine acts on one molecule of bromine. The next reaction, fourth reaction. Quinine acts on one molecule of bromine. Bromine, one molecule just. And the bromine reacts with quinine. The quinine will be converted into bromine substituted product. That is, bromination takes place. Bromination takes place. This reveals the presence of one double bond. One double bond. Since we have a double bond, whenever we add a bromine, this goes and adds to the double bond, will be converted like this. We know the reaction. Br. This reaction is called bromination. Bromination is possible in quinine. As a result, the quinine will be converted into brominated product. This confirms the presence of your double bond. And the next reaction is quinine on oxidation with chromic acid not only gives you the quinone, a ketone that ultimately confirms the presence of secondary alcoholic group, also gives you other product also. The quininic acid, remember the product what we get after bromination is called cinchonine, a famous product. Cinchonine. One of the important products derived from cinchonine, the quinine is cinchonine. Quinine on bromination using bromine, one molecule gives you the product, namely cinchonine. Next reaction, quininic acid treats with soda lime, gives you methoxyquinoline. Quininic acid treated with soda lime gives you methoxyquinoline. Then one more reaction. Quininic acid on oxidation with the chromic acid gives you pyridine 2,3,4 tricarboxylic acid. Quininic acid on oxidation gives you CrO3, gives you pyridine 2,3,4 tricarboxylic acid. See here, you will get this product, COOH COOH COOH. This is your pyridine 2,3,4 tricarboxylic acid. This product. What it reveals? Pyridine on oxidation gives you tricarboxylic acid in position number 2, 3 and 4. We have a carboxyl now. Quininic acid on oxidation gives you pyridine 2, 3 and 4 tricarboxylic acid. This reveals the presence of your, that is methoxy. Presence of methoxy. This particular reaction confirms the presence of methoxy group in position, that is in this particular position, that is in position number, must be a substituent in the benzene ring of quinoline and carboxyl at position 4. Yes, this is your methoxy quininic acid when treated with soda lime gives you directly the methoxy quininic acid when treated with soda lime gives you, as I told you, this confirms the presence of methoxy group, gives you pyridine 2,3,4 tricarboxylic acid, and this confirms the presence of your, this is your methoxyquininic acid. Methoxyquininic acid. And the quininic acid then on treatment with your oxidizing agent CrO3 gives you the pyridine tricarboxylic acid 2,3,4 position. This confirms again the presence of methoxy. One more reaction that confirms the methoxy is reaction of quinine with methyl iodide. One molecule gives you the corresponding product that confirms the presence of your methoxy group. Then we have finally a reaction that confirms yes, quininic acid when treated with hydrochloric acid, and then the product is decarboxylated, you get 6-hydroxyquinone. Then a final reaction that confirms almost the structure of your quinine is this. Quininic acid treated with hydrochloric acid gives you a product. This product on decarboxylation gives you 6-hydroxyquinoline. Therefore, the quininic acid is nothing but 6-methoxyquinone. Quininic acid is 6-methoxysynchronic acid. 6-methoxysynchronic acid. This confirms the quininic acid is your 6-methoxysynchronic acid. What is synchronic acid? Synchronic acid is a product of quinine plus bromine. Quinine plus bromine that confirms the presence of one ethylenic double bond. The product is a famous product, synchronine. So the quininic acid is nothing but 6-methoxyquinone. Therefore, this confirms that both in synchro, that is quininic acid, as well as in quinine, the methoxy group in position number 6. Position number 6. 1, 2, 3, 4, 5 and 6. Therefore, at position 6, we have a methoxy group both in quinine as well as in quininic acid. This product When we oxidize, this will be simply converted into quininic acid. We know very well. The quininic acid is nothing but methoxyquinoline. The methoxy further confirms that the methoxy is at position number 6. So based on the above arguments, we are confirming simply step by step. When you go through slowly again, you will come to know that you will arrive at the conclusion that this is the structure of your quinine. Elucidating the structure of quinine is very easy, not like your big task what we had while discussing the structural elucidation of morphine, structural elucidation of cholesterol, and so on. We have number of alkaloids are there. Those alkaloids are difficult to establish. Those alkaloids are difficult to elucidate its structure, whereas this particular quinine is almost not that much difficult. So friends, be careful. We have a number of reactions we have discussed, starting from the quinine, its a product to quininic acid, quinoline, 6-hydroxyquinoline, synconic acid, then pyridine 2,3,4, tricarboxylic acid, etc., etc. Number of things we have discussed. Bromination of quinine leads to the formation of your synconine, etc. we have discussed in this class. All those reactions are very important in elucidating your structure of quinine. Anyway, I am referring for this particular chapter to discuss a textbook, namely textbook of organic science written by I.L. Feener, famous book. I.L. Feener, other name is I.L. Feener, textbook on organic chemistry. Please refer for further clarification this particular textbook if you have. Please, until then, take care. Thank you for watching and listening my videos.